complete some problems on SFD and BMD. We are starting with the first question. A continuous beam ABCD is simply supported at A and C and is loaded as shown in figure. Here they have given some diagram. The question is, draw SFD and BMD. So this is the beam which we have in front of us. As looking into this diagram, I can say that since the beam is supported at A and C, some portion of the beam is overhanging, that is CD portion. This kind of beam, it can be called as an overhanging beam. Now, whatever diagram they have given, that I will be drawing it again and writing the data. So let us try to solve this problem. In data, I would be simplifying the diagram. Here we have beam ABCD, total length is 7 meters. Next, between portion A to B, there is uniformly distributed load of 10 kilonewton per meter. This is the symbol of UDL. So A to B, that is 2 meter of the distance, and in that we are having uniformly distributed load. And as we can see in this diagram, at point A we are having a hinge support. This is a hinge support. Here is a hinge support. Next, BC portion is 3 meter in length, and at C we are having roller support. This is a roller support. Distance B to C is 3 meters, and the remaining portion C to D is 2 meters. Next, as they have given UDL of intensity 10 kilonewton per meter for 2 meter length, now this UDL I will convert it into point load, that is 10 multiplied by 2, it will give me 20 kilonewton acting at half of AB, that is 1 meter from A. In the downward direction. It is 1 meter from A. Next, at B, the load is inclined. It is having 30 kilonewton value and inclined at 30 degree with horizontal. So this load will have two components. The horizontal component would be 30 cos 30 and the vertical component would be 30 sin 30. So I will be writing the components here. Horizontal component is 30 cos 30 and the vertical component is 30 sin 30. Then we have 10 kilonewton load at point D. Now this is the beam which we have in front of us, and we have to draw SFD and BMD for this given beam. Now let us try to solve this problem. The question is shear force diagram and bending moment diagram. Solution. I will write down step number 1. Calculation of support reactions here. As we can see, the beam is supported at A and C. So at A there will be vertical reaction. I will call this reaction as RA. At C there will be vertical reaction. I will call it as RC. So in the calculation of support reaction, I will say that let the beam be in equilibrium. So I have the first condition of equilibrium, that is summation of all vertical forces is equal to 0, where upward forces are positive and downward forces negative. So therefore, here I can write this as RA plus RC minus 20 minus 30 sine 30, the vertical component in downward direction, then minus 10 is equal to 0. Therefore, I would be getting RA plus RC as it's equal to 45 kilonewton. This will be my first answer. Next, to calculate RA, I will be taking moments at point C. I'll say that the second condition of equilibrium, summation of moments about point C is equal to 0. The convention is clockwise moments to be taken positive and anti-clockwise moments negative. So therefore, if I am taking moment at point C, the first thing is moment of reaction at C would be 0 because it is acting at the same point. Next, if I consider 10 kilonewton, it is producing clockwise moment, so it is plus 10 into 2. Next, here we have 30 sine 30 and it would be producing anti-clockwise moment about point C. So it is minus 30 sine 30 multiplied by 3. Next, here I have 20 kilonewton. The distance from point C is, it is 1 plus 3, that is 4 meters. So minus 20 into 4. At last, I have RA, which is acting upward and it will be producing clockwise moment at point C. So it is plus RA into 5. So therefore, if I calculate all values here, I will be getting my answer of reaction at A as 21 kilonewton. Then I will put 21 in place of RA in equation number 1. I'll say that put RA is equal to 21 kilonewton in equation number 1. Therefore, I have 21 plus RC is equal to 45 and hence my answer of RC will be 24 kilonewton. So now the first step is over. I have calculated reaction at A, 21 kilonewton. Reaction at C, 24 kilonewton. Now after finding the reactions, we can go for the SF calculations. So my step number 2 is shear force calculation. Before doing the calculation part, first write the sign convention. Upward force to left of section, downward force to right of section, both are positive. Downward force to the left of section and upward force to the right of section, both are negative. So now in SF calculation, I will write down first SF at point A, that is shear force at point A is equal to, here my assumption is that I am taking the section just to the right of A. It is very close to point A. This is my section. Now if I take the section, on the left hand side I have upward force, so it has to be taken positive. So it is plus 21 kilonewton.